Hello again, world. Brandon with FastDataScience.ai, and welcome to another episode of This Week in AI, the show where I bring you some of the latest and greatest headlines in data science, machine learning, and artificial intelligence. And so, while Singapore is busy using recycled toilet water to make beer, I'm busy reading through all of the headlines in data science, machine learning, and artificial intelligence, and reporting back today. We'll have three articles that are meant to help edify us on this unique and exciting space of data science, machine learning, and artificial intelligence. Yes, all three, because they all have relationships. Today, I'm also recognizing something. I'm recognizing that this is actually the 25th time I've done this. Okay, and that's a milestone for me because I am really not that consistent in most anything. And so that this is the 25th episode, that means that this is the 25th week that I've done this. And so I am celebrating that fact. And in order to celebrate, I've got three awesome articles to share with you today. We're going to actually be covering how machine learning is being used to improve the job search experience. Yeah. Do you ever wonder why you can't see the salaries on job descriptions for different companies? Well, guess what? Machine learning may have an answer. Another article we're going to cover today has something to do with a very popular topic in the last few weeks in the news around artificial intelligence, and that is tackling the question of whether or not these large foundational AI models are actually creating something like sentience or artificial consciousness. Yeah, we've got a new perspective this week on that debate that brings the conversation into a different realm of neuroscience. More to come on that. But before we go to any of those, I want to start out with the idea that artificial intelligence and machine learning are giving a gut check to our gut. Okay, yeah. So I got inspired whenever I started looking at, sort of how to create some themes around this show today. And this article that we'll cover in a second is really interesting. But I also started looking at different ways to generate images. And I came across a really cool website called crayon.com, CRAIYON.com, which helps users or gives access to users to a language image model that allows you to put in descriptions and return images, very similar to the way that DALL-E works. DALL-E has also been in the news. OpenAI deployed DALL-E, which is a very high resolution model that allows you to submit phrases or word combinations, and it will interpret those to create images. Well, Crayon used to be called DALL-E Mini, developed by an independent researcher and a group of researchers who wanted to essentially try and replicate what OpenAI had done. They built a miniature version of it, and today it is now referred to as Crayon. So when I typed in gut check, this is the disturbing image that I got. Yeah, it looks like some person grabbing through their skin and into their gut. Eh, not a bad representation of my rather vague and cryptic description, but disturbing nonetheless. So I encourage you to go play with it. All right, but I digress. Let's jump into the show. So today is July 8th, 2022. And if there's one thing that I've learned about this show, it's not just that it's This Week in AI. You know, this is the 25th show that I've done, and sometimes I look back on my earlier shows and I still remember things and I still learn things from those that I carry forward, because this field is cutting edge. It's constantly evolving, and a lot of things that come up in the news come up again and again and again. So it's not just This Week in AI, because it's really every week in AI. And we really need to understand how all of these concepts evolve over time. And that's something that I hope that this show really kind of starts to do for you, because it's doing it for me, especially as I'm looking back on this 25th episode and how far I've come, or, well, how far we've come. All right. So as I promised, let's talk about the first article. Machine learning begins to understand the human gut. This article is a really interesting application of how researchers are using machine learning to understand our gut's microbiome. So here's the deal. Probiotics just don't work. I'm sorry if that irritates some of you, my holistic medicine friends. Look, the research is pretty clear on this. If you don't believe me, this is from Scientific American, and it's based off of a lot of studies that were done. And it's just a review of those studies. And the conclusion really is, look, it helps treat some people with gut disorders, but by and large, there are no known benefits for healthy people. None, zero, not substantiated. So, why is that, right? Let's not get so focused on the fact that it doesn't exist. Let's talk about why it doesn't exist. And it doesn't exist because guess what? Our gut is a very complex environment, and the microorganisms, our microbiome, if you will, is quickly evolving, and those organisms and the communities that they create also quickly evolve. Researchers know this, and so researchers have built a machine learning model to predict how those microbiome communities evolve. That is to say, they were able to take features of the environment that those microorganism communities were living in, and then they were able to look at what they changed into, and they built a model that predicted that change. The model was based off a long short-term memory or sequence to sequence model. And what the researchers were then able to do is they were then able to take the model that they had trained on, I believe it was 24 example microbiome communities. Okay, 24 is a very small drop in the bucket when you're talking about over 300 million communities that live in our gut. But they were able to take their model, train it on those 24 example communities where they had these sequences of what happened in the environment before and what happened to the community after. And then they were able to predict new communities. They could take the model and simulate changes to those environments that would predict how different communities might evolve. They didn't stop there. They took the results of their simulations and shared them with another research team, a more biologically driven research team rather than data science driven team, who then took their predictions and tried to substantiate them in their research on existing human microbiomes or microorganisms. Okay, this is as far as I understand it, but this is really interesting because then what they did is they said, hey, look, on these ones you were pretty close, you were right, but on these other ones, no, you were kind of far off. Here are some things that we saw. Those researchers were then able to take those learnings, adjust the weights to the model, create new predictions, and essentially get to a more effective model. So through iteration and through having researchers in the loop, they are creating the potential for a model that might be able to help us understand what probiotics we need to introduce to what environments in our gut that are most likely to proliferate. And that's where we might start to see the benefits. This is super interesting because it's showing how both machine learning and medicine or biology can inform one another, but then also lead to the possibility for even more targeted, I hate to call them drugs, they're not really drugs, but just more targeted opportunities to help introduce things to our bodies that are beneficial. Pretty cool, really exciting. I get all kinds of inspiration out of this. Hopefully you do too. All right, let's move on. So remember when you're doing that job search and you're like looking at a job description and going, why don't I know what this salary is? It sounds cool. Well, guess what? That may be a thing of the past or soon to be a problem of the past because a new artificial intelligence, machine learning model, whatever, can predict salaries based on the text of online job postings. And by the way, not whatever. Artificial intelligence is different than machine learning. They often get conflated. We'll come back to that later. For now, just know that somebody built a model to predict salaries based on text of online job postings. Yeah. Okay, so here's what's happened. We know that hunting for jobs is a full-time job, especially if you don't have one. And different companies pay differently for similar jobs. But rarely do companies actually report what they pay. And in fact, in really bad labor markets or good labor markets, excuse me, where there's a ton of labor, right? So companies can, sort of just go back to the well and grab new people when they need them. They're even less likely to share salary information. So what the heck, man? Like, come on, I want to know what you're paying so I know if I want to apply. Well, guess what? These researchers, they took a sample of 1 million job postings that were provided by a company that apparently creates a repo of job postings. I think it's called greenwich.hr. They built a BERT model on all of the different words and phrases that were in those job postings. BERT is an embedding model. It essentially allows us to create a representation of words and phrases in numbers. And we call those numbers in vector spaces. And so BERT takes a word, for example, and turns it into, say, 100 different columns of numbers. And we call that a vector. So BERT allows us to encode, and that information in those vectors encodes the relationship that words have to other words. And BERT's really cool because it can do it in different contexts as well. Well, these researchers trained a BERT model, then built a prediction model that allowed them to use those BERT-based features to predict salaries. And they did it fairly accurately, but they didn't just stop there. What's cool about this article and what's cool about this approach is they then engaged in a series of simulations called text injection experiments, where they would inject different job postings, varying different elements of those postings, words or phrases, for example, in order to determine how impactful specific words and phrases are on the prediction. You see, when you train a BERT model, or when you train a model using any kind of embedding features on multiple dimensions, we lose the ability to really understand how any one feature relates back to any one word. So what this research does is it actually then uses the output of the models as a research sort of engine, as a way of simulating different possibilities to determine the impact of specific words and phrases on the predicted salaries. At the end of the day, they're starting to build a list of words and phrases that both predict higher and lower salaries. So in the future, what may happen is we may see, like on Indeed.com or something, one, a predicted salary, which I think Indeed is actually starting to do a little bit of. But two, we might actually see some of the words and phrases highlighted as green or red to tell us whether or not there are things in a particular job description that mean the salary could be a little higher or it could be a little lower based on these ideas. Maybe as a job candidate, we know what to emphasize in our interviews, in our skill sets, in order to maybe eke up a slightly higher salary. I don't know, just thinking. But, some really cool ideas here. And I think this approach to leveraging artificial intelligence and also the lack of explainability that we sometimes have in these, sort of embedding neural net models that have lots of parameters and make it difficult for us to understand how anything ties back to some, sort of real piece of data that we do understand. So this is a really cool approach that kind of shows how we might be able to uncover some of that information. Okay, so let's get into what caught my eye for this week. And I don't have a cool image because it wasn't the theme. But what I do want to talk about is the issue of sentience. It's come up again this week, and now we have a different perspective from a neuroscientist. Moving beyond mimicry in artificial intelligence, what makes pre-trained AI models so impressive and potentially harmful? Okay, let's really talk about what this article's take on the problem is. Here it is. Look, sentience is all the rage, and that's thanks to that guy Lemoine, who was that engineer at Google who said, hey, Lambda might actually have feelings. Okay, well, the data science community has weighed in and largely said, yeah, no, buddy, the models don't work that way. This particular article comes from a neuroscientist who has a slightly different perspective. The idea from this particular individual is, look, I understand these large language models, or LLMs, which are also now starting to be called foundation models because they're trained on tons of data, and they're starting to be trained on more than just language data. They're starting to be trained on video or image data or even audio data. Essentially, this individual, this neuroscientist, essentially just asks, are these just big mimicry machines? And he sort of calls them mimicry chameleons. That is to say, they do things that mimic human behavior because they've learned so much about human behavior. They don't actually know what that means or what the impact or consequences of that mimicry is in the real world. They just know that, well, they don't know, right? They just mimic based on a request and based on the context of that request. Well, what this article then starts to uncover is that key element that is missing, which is the idea that we can use our experiences to create sort of world models that give us some naive understanding of how physical objects interact or even inanimate objects interact. And so this gets out to the ability for us to predict based on what we've experienced. Actually, this sounds familiar because last week we talked about how Jan LeCun published a paper on building an artificial intelligence system that, as its basis, develops a world model. That is, the ability to predict in highly uncertain and stimulus-rich environments how objects, animate or inanimate, interact. I want to add a little bit more to this debate and bring in some other perspectives that are both related to neuroscience and psychology. So, as I thought a little bit more about this concept of these large language models or these foundation models being big mimicry machines, I was reminded of the work that happens in psychology around mimicry. See, there's a large. Oh, yeah, I forgot about this picture. So, this was created by Dolly. This is the actual Dolly. So, you see a higher resolution than my gut image at the beginning. But this is what the article starts with. And, all right, I'm just moving on, moving on. So, what we've learned from psychology about human mimicry is that we have a tendency to mimic. And it actually, we mimic more than we even know that we do. That is, it's subconscious or unconscious. And when we do, it has real social consequences. So, for example, people who mimic each other more in a conversation tend to come away from that conversation both liking each other more and liking the conversation more. That is, mimicry has a strategic advantage for us. And in development, we know that children actually excel at mimicking. In fact, it's a lot of the basis for through which they learn. Fast forward to neuroscience, and neuroscience has identified something called mirror neurons in our brains. Mirror neurons exist in different functional areas, including our motor cortex and our audio cortex. And these neurons respond whenever we observe animate objects or inanimate objects doing things in our environment. The idea here is those mirror neurons proliferate when we're young in order to help us develop what I'm going to go ahead and hypothesize are world models. That is the idea here that mirror neurons, the ability to mimic, sets up the foundation for developing an understanding of how the world works. The question is, how do we go from mimicry machines to world models that allow us to then use limited sets of information and apply them to stimulus-rich environments in order to make decisions based off of the experience that we've developed through that mimicry? Okay, that's maybe a little out there, I don't know. I am probably pushing the edge of my true understanding of these things, but trying to bring in multiple different disciplines into a single kind of idea, I think is really where I'm starting to see these conversations go, and I think it's the right direction. I don't know yet, but it's going to be really interesting to find out. And mimicry, the idea that we're building these large mimicking machines, may be the foundation for something like artificial consciousness in the future. I don't know. But whatever it is, I want you to weigh in the comments. Here are the links. I have quite a few more links this week than normal. I'm going to share these in the comments as well with you. But please subscribe. Continue with me in this journey as we learn about artificial intelligence and how it's impacting our world. And let me know what you think. Thanks again for participating in my 25th episode. And I look forward to doing a lot more of these. So to 25 more. Have a great weekend.